Okay, the next topic in GCSE is probability, the study of the chance or likelihood of random events occurring. Now it's on a scale from 0 to 1, where the bottom of the scale is impossible. For example, suddenly growing feathers and being able to fly, chance of that is 0. Up to 1, which is something that's certain. The probability that today's day has an A in it is 1 because that's a certain thing. They all have A's in them, in the English language at least. And then different things in the middle. Picking a red card from a pack, well, half of them are red, so it's a 0.5 chance halfway along that the card you pick will be red. So for example, a bag with some poker chips in, 1 white, 2 green and 3 red. There's 1 chance out of 6 to pick a white, so the probability of a white is 1 over 6. Or, as a decimal, 1 divided by 6 is 0.16666 recurring. Similarly with a red, 3 chances out of 6 to pick a red. 3 out of 6 is the same as 1/2, or 1 divided by 2, which is 0.5 as a decimal. And then finally with green, 2 greens out of 6, so the probability of a green is 2/6, which is the same as a third, or if you do 1 divided by 3, it's the same as 0.3333 recurring. Now, if you add up the probability of all things that are possible, you should get 1. So the chance of a green or a red or a white, 2/6 plus 3/6 plus 1/6 makes 6/6, and that adds up to 1. And that makes sense because you're certain to get a green, a red or a white, and a probability of 1 represents something that is certain. And from that you can say the probability of an event not happening is 1 minus the probability that it does happen. Because, well, for example, we can get a green or we can not get a green. But the chance of getting a green plus the chance of not getting a green must add up to 1, because that's all of the possibilities, and a probability of 1 covers all of the possibilities. So the chance of not getting a green is 1 minus the probability that we do get a green. 1 minus 2/6 is 4/6. And that makes sense because there are 4 chips out of 6 that are not green chips. So the chance of getting a chip that's not a green is 4/6. And 4/6 is the same as 2/3, or as a decimal, 0.6666 recurring. And then in the same vein, in the same idea, to find the probability of one event or another happening, we add them up. So the chance of a white or a green, you just take the chance of a white and add it to the chance of a green. So there's a 1/6 probability of getting a white, 2/6 probability of getting a green. So the chance of getting a white or a green, we add them up to get 3/6. Makes sense because 3 out of the 6 chips in the bag are the whites and the greens. 3/6 is the same as a half, or 0.5 as a decimal. Now it's less obvious to see that to find the probability of one event and another happening, we multiply. So for example, Casper picks a chip and he puts it back. Morton does the same. What is the probability that they both pick green? Well, Casper's got 6 chips to pick from, and 2 of them are green, so he's got a 2/6 chance of picking a green, so he'll do it 2/6 of the time on average. Morton, it's the same for Morton. He's got 6 chips to pick from, 2 of them are green, so on average he'll pick green 2/6 of the time. So for them to both do it, that's got to happen 2/6 of 2/6 of the time, because they've both got to do it. Of with fractions always means times, so 2/6 of 2/6 is 2/6 times 2/6, which is 4/36. So for them to both pick green, that's going to happen 4/36 of the time. So the probability of them both picking green is 4/36, which is the same as a ninth, or 0.111 as a decimal. Now in that situation, they picked out the chips and then they put them back. But what if Casper picked his chip out and didn't put it back? So it makes a difference whether we replace things. So this time Casper picks his chip out and doesn't put it back. Morton does the same. What is the probability that they both pick green? Well, first of all, Casper has 2 chances out of 6 to pick a green, like he did before. But then if he does that, the green is out of the bag, like in the picture here. So when Morton comes to pick his chips, he's only got 5 chips to pick from, and if Casper's picked a green, there's only 1 green left. So for them both to pick a green, you've got the 2/6 chance that Casper picks a green, and then if that happens, only a 1 out of 5 chance for Morton to pick the green. So the chance of them both picking the green is 2/6 times 1/5, which comes to 2/30, which is the same as 1/15, or as a decimal 0.066666 recurring. So remember to think about whether things are being replaced if you get an exam question like this. Now you can use tree diagrams. So first tree diagram is about the first example where they take the chips out and put them back. So the first is the first person picking the chip, red, green or white, with 3/6, 2/6 or 1/6 chance probability. And then you can have red followed by red, red followed by green, red followed by white, or green followed by red, green or white, or white followed by red, green or white. And this is with them putting the chips back, so the second person that picks has always got probabilities out of 6, because there are always 6 chips to pick from. And we can work out the probabilities overall of each way that this can end up. So a red followed by a red, that's 3/6 times 3/6. So the chance of that happening is 3/6 times 3/6, which is 0.25. And you can do that with the rest of them. Work out the probabilities of each possible outcome in this situation. Now, because this diagram covers all of the probabilities, then all of those probabilities that we've just worked out should add up to 1. If you actually do it with those decimals there, it's slightly over 1, but that's just because of rounding numbers off. If you do it very accurately, then it is 1. So that's example 1, picking the chip out and putting it back. But example 2, picking the chips out and not putting them back. So this time the probabilities for the second person are all out of 5, because they've only got 5 chips to pick from. And again, we can multiply these out to work out the probabilities of each possible outcome. So red has a probability of 0.2, and so on, just multiplying the branches out to work out the probability. You'll notice that the probability of white followed by white is 0, because there's only 1 white in the bag, so if they're not putting them back, they can't pick 2 whites. And again, these numbers should add up to 1. Actually, because of rounding error, they're a bit over, but with complete accuracy, they do add up to 1.